Okay, next example, example 3. Okay, find the coefficient of x to the power 5 and x to the power minus 3 in the expansion of, okay, this whole thing over here. Okay, it looks very complicated, but these are actually from example 1 and example 2. Okay, so what we do is, first we expand each of them, which I believe I don't need to go through in detail, you should already know how to do it, and you can get the answer from example 1 and 2. Okay, so okay, it looks very complicated, but don't worry, we are not going to expand any further. What we do here is we want the coefficient of x to the power of 5, right? If I multiply term by term, it will be too tedious. So what we are going to do is we are going to observe which terms do I need to multiply to get x to the power of 5. Okay, so let's look at the terms here. If I want x to the power of 5, I need to multiply x to the power of 4 by minus 3x. Okay, and I also can I'll need to also multiply x to the power of 2 to x to the power of 3 to get x to the power of 5. Okay, and that's all, nothing else, no other multiplications will give us x to the power of 5. Okay, so you can see that, okay, coefficient of x to the power of 5 will simply be, okay, minus 3 plus 4 equals to 1. Okay, minus 3 is when I multiply x to the power of 4 with minus 3x, I get minus 3 as the coefficient, and 4 is when I multiply 4x squared to x cubed. The coefficient will be 4. Okay, so when you add them, you get coefficient of x to the power of 5 equals to 1. Okay, next, you want to get the term in x to the power of minus 3. So let's look again at which terms do we need to multiply to get this power. Okay, x to the power minus 3. Okay, so if, okay, I will need to multiply 6 to minus 1 over x cubed. Okay, we'll get minus 6. And then we need to multiply 4 over x squared to 3 over x. We'll get plus 12. And we multiply 1 over x to the power of 4 to minus 3x, we get minus 3. Okay, so when you add them together, you get 3 as the coefficient of x to the power of minus 3. Okay, so this is what you have learned in secondary school when you expand expressions when the power is a positive integer. So we are going to move on to the binomial theorem for rational indices. Okay, this means that the power, okay, may not be a positive integer. It can be negative or it can be a fraction. Okay, so okay, you look at the formula. This is 1 plus x to the power of n. It is equals to 1 plus n times x plus n times n minus 1 over 2 factorial times x squared plus n times n minus 1, n minus 2 over 3 factorial plus x cubed, and so on. Okay, this formula can be found in your formula list. Okay, so you don't need to remember it. Okay, just look at the formula. You see that there are 3 dots here, right? Okay, it will only be 3 dots, not 4 dots or 5 dots or 6 dots. Okay, because this is actually a mathematical symbol. Or it's not even 2 dots, okay? It's a mathematical symbol called ellipsis. Okay, it will always be 3 dots. So when you do your tutorial and assignment, make sure you always write 3 dots. Okay, if you look at the condition here, okay, the power n can be belongs to the set of rational numbers. So it can be any number as long as it is rational and there is a condition for x. Okay, the modulus of x must be less than 1. Okay, why is this so? We will come to look at it later. Okay, but for time being, okay, a few points to take note. The number of terms in this expansion is infinite, as you can see from the ellipsis here, the dot dot dot. Okay, it goes on forever. Okay, and note that in this case, right, when n is not a positive integer, okay, we do not use the notation n choose r. Okay, we only use this notation when n is a positive integer. Okay, when n is not a positive integer, Okay, we use a bracket notation that you have seen earlier. Okay, point 2. The expansion is in ascending powers of x. Okay, so as you can see from the formula, you have x to the power 1. Okay, the first term is actually x to the power 0. Second term, x to the power 1, x to the power 2, x to the power 3, and so on. So we say the expansion is in ascending powers of x. So we look at one example. Okay, we have 1 minus x squared to the power of minus 1. So in this case, n is equals to minus 1. So looking at the formula, okay, when I expand it, my first term I'll get 1. Second term, I'll get nx. So it means that I will have a minus 1, and my x in this case is actually minus x over 2. So this is my first term, and my second term, this is n times x. And the third term, I have n times n minus 1 over 2 factorial x squared. So n is actually minus 1. So n minus 1 will be minus 2. So I will have minus 1 times minus 2 times minus x over 2 to the power of 2 plus dot dot dot. Okay? And then you simplify it, you will get 1 plus x over 2 plus x squared over 4 plus dot dot dot. Okay, now at this point, some of you may ask, how many terms do you need to expand till? Okay, this depends on the question. Usually the question will let you know that they want the expansion till the term in x squared or the term in x cubed. So you would just expand accordingly. Okay, so next slide. Okay, same thing here. We also have a general term. The general term is the term with x to the power of r, or the r plus 1 term. And this is given by the formula tr plus 1 equals to n times n minus 1 times n minus 2 all the way till n minus r plus 1 over r factorial times x to the power of r. Okay, the binomial expansion, as you can see from the earlier formula, it has to be of the form 1 plus something, 1 plus fx to the power of n. Okay, so if you cannot remember, you can refer to the formula again. You see that it is 1 plus x to the power of n. So it always has to start with 1. So what if you have something that starts with 2? We have a question like this, 2 minus x to the power minus 1. What we can do is, we factorize out the 2. Okay, so you have learned, okay, so we factorize out the 2, we'll get 2 times 1 minus x over 2 whole thing to the power of minus 1. Okay, as you have learned from indices, okay, when I have something times something to the power minus 1, I can bring in the power, so I will have 2 to the power minus 1 times 1 minus x over 2 to the power of minus 1. So you see that this 1 minus x over 2 to the power minus 1 is the example that we did earlier. Okay, so just now we mentioned that, okay, point number 5, the expansion is valid for a restricted range of values of x, i.e. the expansion is of 1 plus fx to the power of n is only valid when the modulus of fx is less than 1. So for example, okay, we use the same example, 1 minus x over 2 to the power minus 1. Okay, this expansion is valid only when the modulus of negative x over 2 is less than 1. Okay, so when I have modulus of negative x over 2, it is actually equals to the modulus of x over 2. Okay, do you know why? Because if let's say I have the modulus of minus 5, it is equals to the modulus of 5. So in this case, modulus of minus x over 2 is equals to the modulus of x over 2. Okay, now I can, because 2 is positive, I can bring it over. So I will have modulus x is less than 2, which I can further simplify to x being between minus 2 and 2. Okay, at this point, some of you may not understand how I get from here to here. So, for those who understand, you can fast forward. If not, I will show you how I get from mod x less than 2 to be x between minus 2 and 2.